Welcome, ladies and gentlemen. Today we'll be solving another differential equation. And here we are given the differential equation dy dx is equal to 12 divided by the quantity 3x plus 2 squared times e to the y minus 2. We are given the initial condition of y of 0 is equal to 2. That means x is equal to 0 and y is equal to 2 when we have to find c for this particular solution. C is a constant from an indefinite integral, and c can be a variety since an indefinite integral has a variety of solutions. So let's begin. It might look a little scary at first, but it is not scary. We're going to separate the variables. So we want to get the y's on one side and the x's on one side. We times y e to the y minus 2 on both sides, and we times dx to both sides. So we can then have the variables separated. We are then left with e to the y minus 2 dy is equal to 12 divided by 3x plus 2, the quantity 3x plus 2 squared dx. We're going to rewrite this equation before we integrate. So we're left with e to the y minus 2 dy is equal to 12 times the quantity 3x plus 2 minus to the negative 2 power dx. The reason why I put it to the negative 2 power is because we're going to use u substitution for this integral. So we have the indefinite integral of e to the y minus 2 dy is equal to the indefinite integral of 12 times the quantity 3x plus 2 to the negative 2 power dx. Let's start with the integral on the left, the integral of e to the y minus 2 dy. So the integral of a number to any power is equal to this formula, so long as a is greater than 0 and it does not equal, this is actually supposed to be 1, my bad, and it cannot equal 1. So in this situation, our u will be the y minus 2, and our a will be our base, our e. So the integral is going to be the integral of e to the u du is equal to eu ln e. So, which turns out to be e to the u divided by 1, since ln e is equal to 1. This turns into e to the u. So the integral of this is equal to e to the u. We plug in this u back into this. So the integral of e to the y minus 2 dy is equal to e to the y minus 2 power. So it's basically back to that. It's just this back again. Now let's take the integral of the right side. So we have the integral of 12 times the quantity 3x plus 2 to the negative 2 power dx. This, we're going to have to use u substitution. So we put the 12 on the outside of the integral because we can always multiply it back if we want to. So 12 times the integral of 3x plus 2 to the negative 2 power dx. So we're going to want to do u substitution. So our u is this right here, 3x plus 2. But we want to have du. not dx. So what we do is we're going to derive u. The derivative of 3x is 3 dx. And as you can see, to find dx, divide both sides by 3. Dx is equal to du divided by 3. 12 times the integral of u to the negative 2 power du divided by 3. We can now take this 3 and put it over here, divide the 12 by the 3. And we're left with 12 divided by 3 of the integral of u to the negative 2 du, which is just going to be 4 times u to the negative 2 power plus 1, and negative 2 plus 1. This will turn into 4 times u to the negative 1 divided by negative 1, so that it becomes negative u to the negative 1 times 4, negative 4u to the negative 1. And when anything to the power of negative 1 is 1 over that number, so in this case it's u, negative 4 divided by u, and remember that u is 3x plus 2, so we're going to plug that back in. Negative 4 divided by 3x plus 2 is equal to the integral of 12x times the quantity 3x plus 2 to the negative 2 power dx. And now that we have both sides integrated, we can now solve for c, since this should be negative 4 divided by 3x plus 2 plus c, since this was an indefinite integral. Because an indefinite integral has a variety of solutions, but with our initial condition, we can soon solve for c. So e to the y minus 2 power is equal to negative 4 divided by 3x plus 2 plus c. Now we were given the initial condition of x equals 0 and y equals 2. So we're going to just plug that back in. So e to the 2 minus 2 is e to the 0 is equal to negative 4 divided by 3 times 0 plus 2 plus c. E to the 0 is equal to 1. Negative 4 turns into negative 2. Now we're solved for c. 1 plus 2, negative 2 plus 2. C is then equal to 3. Now we're going to plug in c back into our general solution, which our general solution is actually this right here. So we plug in c back into our general solution, and we have e to the y minus 2 is equal to negative 4 divided by 3x plus 2 plus 3. And now we're going to solve for y. We take the natural log of e to the y minus 2, and when you take what you do to one side, you do to the other. So you take the natural log of this part of the equation, so it's negative 4 divided by 3x plus 2 plus 3. And when you have the natural log of e, that becomes 1. So it should become y minus 2 is equal to the natural log of negative 4 divided by 3x plus 2 plus 3. And then do some simple algebra, and you're left with y equals the natural log of the quantity negative 4 divided by 3x plus 2, that quantity plus 3, and that natural log is plus 2.